Hello and welcome all my grade 10 advanced students to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. The session is for the grade 10 advanced students who are going to give the exam on Monday. In this session, we are going to cover from the FRQ Learning Objective 21, where you will solve questions on factorization, where you will do the questions 60 to 70 from page 682, where you factor perfect square trinomials. So let's get started with the video and watch the video till the end. Don't forget to like, share and subscribe so that you can get the answer key and also be notified of the upcoming revision videos. Let's get started. Now, if you see the question properly, there is a trinomial given to you. Now, for this trinomial, you have to check whether it is a perfect square trinomial or no. So let's recall what is a perfect square trinomial. A perfect square trinomial satisfies three conditions. What are those three conditions? Let me write. If it is of the general form ax square plus bx plus c, this is any trinomial. How do you know it is a trinomial? 1, 2, 3. It has three terms. And now when does this trinomial become a perfect square trinomial? So there are three conditions. The first condition, the first term has to be a perfect square. Similarly, second condition, the last term also needs to be a perfect square. So if I may just give an example, the first term should be of the form a square, the last term should be of the form b square, and the middle term which you get after the multiplication should be of the form 2 multiplied with the first term multiplied with the second term. Now I want you to remember that here the first term is a perfect square, it is a square. The last term is b square and the middle term is just the square root. It has a and b only multiplied. It does not have a square and b square. So don't do the mistake. Now let's check for this given question. I will write the terms now. 9x square plus 50x plus 25. Let's check whether these three conditions are true or no. I'm picking it up from here. So let's first go for the first term. This is the first term. Now, is 9 a perfect square? Yes. Of which number 3? Is x square a perfect? Definitely of x. So can I say the first term can be written as 3x whole square, and the condition number 1 is true. Yes, it's a perfect square. Let's look at last term. Last term is 25. Again, it is the square of 5. It's a perfect square. So if you see carefully, the first condition and the last condition for the last term is true. Now let's look at the middle term which we get after the multiplication. So here the middle term is 50x, and as per the formula, as per the rule, the middle term should be 2 multiplied with the square root of the first term. So square root means only I take 3x, not 9x square. Similarly, I only take for the last term 5. So if you just multiply all of this, 2 multiply with 3 is 6, 6 multiplied by 5 is 30x. So the perfect square should have 30x. But does this have 30x? No, it does not have 30x. It has 50x, which is different. So can this be a perfect square trinomial? Yes or no? Definitely the answer is no. So Debini is wrong. She is not correct. And this perfect square trinomial 9x square plus 50x plus 25 does not satisfy this condition. So therefore it is not a perfect square trinomial. Now second part, if she is incorrect, which is the right answer, show how the expression can be changed so that it becomes a perfect square. So when does it become a perfect square? If the middle term is 30x. So now let's try and factor. So this is the first term square. Now if the middle term becomes 30x, then we are done. Then we can use the identity a square b square plus 2 times a times b. So what is that identity? A plus b square. So I will write here a plus b whole square is equal to a square plus 2ab plus b square. So this is the algebraic identity that I'm going to use for solving this question. So now we can do the perfect factorization and it has become a perfect square triangle. So this is how you will solve the question. Do mention all the steps and the identity that you use while you solve the FRQ paper-based question. So on this slide, I have provided you all the steps nicely along with the answer key. It is same as what I have explained you. So do remember that if you get paper-based exam, you show all the steps if you want full marks. And don't make silly calculation mistake. Very important. Let's move to the next important question. This is also on the concept of perfect square trinomial. So the three conditions which I stated in the last question, I'm going to use exactly the same condition while solving this question, but in a different way. So in this question, we have to find the value of m that will make this expression. It has three terms, but I don't know the value of m. That's what I need to find. And we have to make this trinomial a perfect square trinomial. So first we need to find the value of m, and after we convert it to a perfect square trinomial, putting the value of m, we need to factor also. So it's a long question. So let's write the term 4x4 minus 44x2 plus m. We need to find m. Now just see carefully how I solve. Okay, so this is my first term which is referring to my a square. This is my second term which is referring to my b square. And this is my middle term. Also notice there is negative sign. Refer to minus 2ab. Okay, so these are the three conditions. The first term needs to be a perfect square. The last term needs to be a perfect square. So can I say this term, this value m should be a perfect square. For example, let's assume it is b square. Yeah, we want that. And the middle term has to be the product of a multiplied with b multiplied with 2, and there's a negative sign. So this time I will use the identity a minus b whole square is equal to a square plus b square minus 2ab. Just keep this in mind. In this question we are using the negative identity. In the last question we use the positive identity. So please carefully note the sign. Okay, now let's proceed with the question. So if the first term is a perfect square like a square, then I need to see it is the square of which term. So what is the square root of 4? 2. What is the square root of x to the power 4? Now the power is 4. So if I take square root, power will reduce. So it will become 2. So this 2x square is the first term which is a perfect square. Now last term I'm replacing m with b square. Why I do this? Because I want this term also to be a perfect square. Because I want the whole trinomial to be a perfect square trinomial. Now let's try and change this minus 44x square in terms of minus 2. So minus 2 times is the first term given to you? Yes. 2x square is the second term given to you. No, I don't know. It is b, right? I don't know. So I have written this question, this trinomial in this form. Now I need to find the value of m. So to get the value of m, I need to find b. If I know b, I know m also. So this value and this value same, this value and this value I put same. So can I say the middle term will also be equal to this expression? So minus 2 times multiplied 2x square with b, this whole term, the middle term I'm taking, I'm just putting the two middle terms as equal. So I take this minus 2 multiply with 2x square first term multiply with second term. This is equal to what? It is already given in the question, minus 44x square. Correct? Now let's try and solve this. Some cancellation will happen and eventually we'll get the value of b. The moment I get value of b, it's easy for me to find the value of m. So that's the approach I'm going to take. Okay, so first things first. Both have negative sign. I make it positive. Now 2 multiplied by 2 is 4x square b is equal to 44x square. Now think and tell me what will cancel. Yes, you're right. X square khalas. How much is b? 44 divided by 4. It is 11. And is 11, if the value of b is 11, how much will be your m? 11 square, which is 121. And not to forget that yes, 121 is a perfect square And 121 is the perfect square of which number? 11. Because if you check your calculator, 11 multiplied by 11 is 121. So what is the value of m? The value of m is 121. So now I can put back the value of m here in this expression, and the second part we can proceed where we need to factor. So let's factor. So I will continue from this step. So 2x square, this is the first term, perfect square. The second term is 11 perfect square, and the middle term now can be written as 2 times 2x square multiplied by 11. So now it's a perfect square identity, perfect square trinomial. So I can use the difference, this identity, a minus b whole square. How do I know I have to use this negative sign? Because there is negative sign in the question, if you see, right? Here also. So the first term a square is how much? 2x square. The second term b, how much? We just now found 11. And what is the sign in between? Negatives. This is gonna be my final answer. What are the two factors? 2x square minus 11. It is a repeated factor. How do you know it is repeated? The power is. This is gonna be the final factorization for this question. So now here on this slide, as promised, I have provided the step-by-step answer key. I have explained to you in the previous slides the same answer but in a more simplified form. I hope it is easy for you. And with that, let's move to the next question. In the next question, we need to find the error. There are two people here, Elizabeth and Lorenzo, who are factoring an expression. Now you need to check out of these two, who is correct, Elizabeth or Lorenzo. So let's see in detail what they have done, and we also need to explain your reasoning. So these are all like higher level critical questions. So first observe which identity will work for you while you are going to factor this expression. See here, 16 and 25 both looks like perfect square. 16 is the square of 4 and 25 is the square of 5. Yeah, perfect. Now look at the variables x to the power 4. So x to the power 4 is the square of x2, x2 to the power square, and y square is definitely for y to the power 2, right? Similarly, if you look at Lorenzo, he is also trying to factor the same expression. But let's see who is correct. Only one is correct, Elizabeth or Lorenzo. So I hope first step this one is clear. Now let's think which identity is going to work. So in this case, the first term is a perfect square. If you just, I will write once more. This is the question. Huh? This is the thing that they both are trying to factor. Now, if we know all of these are perfect squares, so can I replace 16 with 4 and x4 with x square as the perfect square and then write power 2? I am using this and this to do the simplification. Now there is a negative sign, mind you. 25 is the perfect square of 5. Y square is the perfect square of y. So 5 square. Okay. So now think which identity. The first term is a perfect square. The second term is a perfect square. And there is difference. So this is the difference of square identity, which is having two factors, one with plus, one with minus. And mind you, when you do the factorization, you take the square root of a and b. Okay. What is the final answer? Let's do it now. After I apply the identity. So the first term for x square, first term x square. What is the difference? One is plus, one is minus. Let's write the second term. How much? 5y. 5y. So this is the correct answer. So now think, tell me who's correct? Is Elizabeth correct? No, because she forget the power here for 4x square. So this one is definitely wrong, and the one which is correct is Lorenzo because he did not do the mistake. Now let me clarify one important point. You can write first the positive, then the negative, or you can also write first the negative, then the positive. Both are correct. Order is not important. So therefore, Lorenzo is correct. And if you get such a question, it's very, very important to mention the identity which you use, which is nothing but difference square. So do mention the identity, and this is how you explain your reason. Let's check the answer key for the next slide. As I already explained to you that for this question, Lorenzo has given the correct answer. Elizabeth made a mistake. So the power which should be there for x is correct in case of Lorenzo, not Elizabeth. This is how you will show the steps. And do remember to mention the identity difference in squares that you used for this question. Let's now do another very important question, which is again from the topic of factorization, and it's very clearly mentioned in the keyword that you have to use difference of square. That means you have to use the identity a square minus b square is a plus b multiplied with a minus b. Now let's copy the question which is given, 9 minus k plus 3 square. Now, step one, how do you know? How do you convert this to the form of difference of square? Check, is the first term a perfect square? Is 9 a perfect square? Definitely yes. How do you check? You use your calculator, plug in square root 9, you will get 3. So 9 can be replaced with 3 square. It's a perfect square. Look at the second term. The second term here is k plus 3, and yes, it is already given with power 2. It's already given in the perfect square form. So we are ready to apply the identity, and now we will convert and put the two brackets. One will be positive, one will be negative. So let's write the terms. The first term a is same for both. It is what? It is the square root of 9. So I'm going to put 3 on both sides. The second term is k plus 3. So I'm going to copy k plus 3 here, k plus 3 here. Now, one important mistake that you can do. Here there is a negative sign. So when we put k plus 3, we need to put bracket. And when I'm going to open the bracket here, the sign of the inside term will change. Let's see what will happen. So the first bracket, very easy. 3 plus 3, 6 plus k. I just simplify and add the like term. Now for the second, because of the negative sign, I need to be extra careful. We should not make any mistake. So let's do it carefully. So 3, now k first inside the bracket positive, outside negative. So it will change sign, become negative. Again, 3 has positive sign inside the bracket. Open the bracket, negative sign makes it minus 3. So this is very important. Now if you see second bracket, plus 3 minus 3 cancel class. So there is only negative k left with the negative sign and 6 plus k. Now you can leave your answer here, but if you read the question says simplify. Till here the answer is very correct. But let's also simplify. That means we will do distributive property, open the bracket. So final answer would be negative, negative sign changes inside. So 6k minus k square. This is how you factor, simplify, use the difference of square and give the final answer. Check the final answer key in the next slide. So as promised, this is the answer key with all the steps. Make sure you present your answers well. Don't do any silly calculation mistake. And do mention the identity difference of square very neatly, very correctly with all the steps and the working to get full marks. Best. Okay, so let's solve the next question. This is on the topic of perfect square trinomial that we have already studied in today's session. So, the three conditions we need to check. And out of these four, 1, 2, 3, 4, we need to find the odd one out, the one that does not belong. Also, we need to give reason, explain why. So, if you check all of them one by one, let's divide the screen four parts and then one by one we do. So let's check the condition. First term, is it a perfect square? 4x square. Yes, of the term 2x whole square. Is the last term a perfect square? 81. You can check using calculator, put square root 81, you'll get 9. So it's the perfect square of 9. Middle term, minus 2 times 2x times 9. Let's check the middle term. Is it coming same? 2 with 2, 4. 4 with 9, 36. So yes, minus 36. So it is giving me the correct value. So all the three steps that we need to check for perfect square trinomial, namely the first term is a perfect square, the last term is a perfect square, and the middle term is the product of 2 times square root of first term and second term is true. So yes, it is a perfect square trinomial. What about the second one? Let's check. Again, the first term is the perfect square of 5x square, 1 is always a perfect square, and the middle term is 2 times 5x times 1. So yes, this is also a perfect square trinomial. Let's check the next one. 4x square. Can I write this as 2x whole square? Yes, it's a perfect square. What about 4? 4 can be written as perfect square of 2. 2 multiplied by 2. Let's check middle term. 2 times 2x times 2. How much? 2 multiplied by 2 with 2, 8x. But what is given in the question? 10x. It's not equal. So no, this is not a perfect square trinomial. Till now, it feels like 4x square plus 10x plus 4. This is the odd one out. It is the only expression that is not a perfect square trinomial. But before that, let's check the last. Okay, 9x square. This is the perfect square of 3x whole square. First term is there. 16 is also the perfect square of 4. And let's check the middle term. 2 times 3x times this would come out to be, oh, there is a negative sign also. So negative 2 multiplied by 3, 6 with 4, 24x. Yes, it's the same thing. Again, this one is also a yes. So which one is the odd one out? Only odd one out is this one because it is not a perfect square trinomial. So this is how you say that the trinomial that does not belong in this category because all others are perfect square trinomial is the third one, 4x square plus 10x plus 4. Okay, let's do the last question for this video. Here the hint is, it's given to you already in the question that you need to use the identity difference of square that we've already worked on so many times in today's session, and you are going to use this to factor and simplify this given expression. Now this question becomes a little tricky because if you see the powers are more, the numbers are big, but any which ways, the still same identity, difference of square is going to work for you if you don't make any mistake. So let's first go to the numbers. The number given is 121 here and 16 here. Are they perfect squares? Let's check. Yes. This is 11 square and this is 4 square. So definitely I can apply the difference of square. Now coming to the variable part, there is x, y, z involved. Now what is the power of x? So we want to factor this in perfect square. So I want to write it as a power of 2. Now if it is x square, then inside can be only x to take like basically the square root. Similarly, how do you do it on your calculator? Put y to the power 6. Now what is the square root of 6? Like as in what you need to multiply to 2 to get 6? It is 3. So why 3? What you need to multiply to 2 to get 4? 2. So this one. So I can say that x square y6 z4 is the perfect square of x to the power 1, y to the power 3, z to the power 2. Similarly, if I take the other one, y square z square, this is the perfect square of y, z. So all of these terms are perfect square. All my condition for difference of square is valid. So I can now proceed and replace with the identities. What I'm going to do, I'm going to replace the first term, this one, with this and this. So I'm going to replace my 121 with 11. I'm going to replace my x square y6 z4 with x y cube z square and now give it a power 2. So what I've done, I've basically rearranged, rewritten the same thing in a square form. Now in between we have negative sign because we're applying difference of square, and let's now write the second term also. So now I'm going to use the second part, which is 16 is the square of 4 and y squared z squared is the square of y squared. So I hope this step is clear. We have used our calculator and a little bit of algebra for this step. Now we are ready to apply difference of squares. So two factors will come, one with plus, one with minus. So let's write the factors now. The first factor is 11x y cubed z square. I'm going to copy the same factor here. And the second factor is 4yz. I'm going to write it here. Yes, we have to change the sign also. So one is positive, definitely the other is negative. This is one way of doing the factorization using difference of square, which is very, very correct. Now, just to add to it, there's one more step written here, simplify the expression. So yes, we can take something out common. Now, if we want to really observe what is common in the first and the second term, 11 and 4, nothing common because 11 is odd, 4 is even. Number, I cannot take anything. Let's go to variable. X is here, but X is not here. I cannot take X out. But in this one, there are 3y and here it is 1y, 1z. So can I take 1y and 1z common from the first bracket? Yes, what's left? 11 x. Now from 3y, I take 1y outside, so 2y left. From 2z, I take 1z out, so 1z is left plus 4. Similarly, from the second bracket also, I can do the same. I can take 1y and 1z out and I'm left with the same term but with a negative sign. Now let's rearrange. YZ and YZ are multiplied. So power 1, power 1 becomes power 2. So Y2, Z2 and I'm left with the same term. So this can be the final answer which we have simplified by taking the common factor out. So let me just summarize this for you. If this question comes and you leave your answer here also, you'll get full marks. But if you simplify it further, I would advise this is a better way of doing it, and it's like a very good method and you'll get 100 out of 100. Full marks for this question if you also do the simplification just like I did here for you. Let's check the answer key for the question in the next slide now. So as discussed, this is the final solution for the question. Now, if you see in the last step, they have not done much of a simplification. So this is also a correct answer. And if you do one step extra, take the common factors out and give the final simplified form, that will also give you the correct ways. Just make sure you write the identity difference of square that you use and all your steps properly and don't do any silly sign or calculation mistake. All the best. With that, we've come to the end of today's session. I hope you found the video useful for your grade 10 EOT revision. And if you want more videos like this, do comment which topic you want me to cover next, and also share this video with all your grade 10 advanced friends who are going to give the math exam on Monday. Like, share and subscribe to the channel. Until then, this is Ms. Vishika signing off from today's video. See you in my next session. Bye bye.